I'm TorqueTon, and I've analyzed 17 specific modern car features that are quietly destroying engine life. Here's the brutal truth. Your advanced engine is a ticking time bomb. Automakers have created the most fuel-efficient engines in history, but they've done it by pushing mechanical limits to the breaking point. Some efficiency features in modern cars may trade off added complexity for potential longevity risks that could emerge after the warranty period. Today, we're exposing how features marketed as advanced technology are actually engineered compromises that transfer maintenance costs directly to you. Small displacement turbocharged engines work twice as hard to produce big engine power, and that creates catastrophic thermal stress. A 1.5-liter turbo pushing 250 horsepower runs cylinder pressures and temperatures that would make a naturally aspirated V8 sweat. The problem is manufacturing tolerance. These engines have little room for error. During high-speed highway driving, exhaust gas temperatures can exceed 1,800 degrees Fahrenheit, hot enough to melt copper, pushing turbo bearings and oil beyond their design limits. Engine overheating can cause severe damage, including warped cylinder heads, blown head gaskets, or cracked engine blocks, potentially leading to engine failure if not addressed. If you're buying a downsized turbo for towing or aggressive driving, expect major repairs by 80,000 miles. If you're using it for gentle commuting with proper cool-down procedures, it might reach 150,000. The key is understanding that efficiency and durability are opposite engineering goals. The efficiency trap gets worse with lubrication. Modern engines use ultra-thin 0W16 and 0W20 oils paired with low-tension piston rings to reduce friction and boost fuel economy. But here's the catch. The low-tension rings have weaker spring force, which allows more oil blow-by into the combustion chamber where it burns off. This creates two problems: higher oil consumption and carbon deposits that stick the rings in their grooves. Short-trip driving makes it worse because fuel dilution thins the oil even further. Here's the trap. The thinner oil flows better through tight VVT solenoids and micron-level bearing clearances, but it breaks down faster under heat and contamination. Some owners following 10,000-mile service intervals report increased engine oil consumption at higher mileages. If your engine uses more than a quart between changes, those low-tension rings are already failing. Stick with 5,000-mile intervals regardless of what the manual says, or prepare for a $4,000 ring job. Direct injection engines spray fuel directly into the cylinder, which means fuel no longer washes the intake valves clean like it did with port injection. Without that cleaning action, carbon buildup forms thick deposits on valve surfaces, restricting airflow and causing misfires. EGR systems make it worse by recirculating exhaust gases loaded with carbon particles directly onto those same valves. Walnut blasting is often a common professional service for removing carbon buildup from direct injection engines, typically recommended every 30,000 to 60,000 miles at a cost that can range from $800 to $1,200 depending on the vehicle, though alternatives like chemical induction cleaning exist. Here's the devastating part. If you ignore the buildup, carbon chunks can break off and damage pistons, catalytic converters, or lodge in valve seats. Many BMW and Audi owners learn this the hard way when a $1,000 carbon cleaning becomes a $8,000 engine rebuild. If your direct injection engine idles rough, hesitates on acceleration, or throws random misfire codes, carbon coking is already destroying performance and heading toward catastrophic failure. Automakers replaced metal coolant tanks, water pump impellers, and intake manifolds with plastic to cut weight and cost. These plastic components become brittle after repeated heat cycles and crack without warning, typically between 60,000 and 90,000 miles, right when most people think they're past the major repair phase. A cracked coolant tank dumps your entire cooling system in minutes, causing immediate overheating that warps heads and ruins engines. Plastic water pump impellers disintegrate and send debris through your cooling system. The financial impact can be brutal. In many models, a $200 plastic part failure can often destroy a $15,000 engine because you typically never see it coming. Start-stop systems and cylinder deactivation like GM's AFM are controversial because they create mixed friction scenarios. When the engine stops, oil can drain from the bearings and cylinder walls. When it restarts, there's a brief moment of metal-on-metal contact before oil pressure rebuilds. After 100,000 plus cycles in stop-and-go traffic, this adds up to measurable bearing wear. Cylinder deactivation creates different problems: collapsed lifters and stuck valves from uneven oil flow. However, modern systems use electric oil pumps and pre-lubrication to minimize damage. The risk depends on your driving. If you're mostly highway, these systems work fine. If you're in stop-and-go traffic daily, consider disabling them or budget for early bearing replacement. Critics call 0W16 and 0W20 oils watery and claim they destroy engines to gain 1% fuel economy. They argue thicker oils provide better film strength and bearing protection. However, modern engines have micron-level tolerances that require thin oil to flow through tiny passages to VVT solenoids and timing chain tensioners. Using thicker oil can actually starve these components and cause timing system failures. The controversy centers on older mechanics trained on different engines versus engineers designing for specific clearances. If your manual specifies 0W20, that's what your VVT system needs to function. Using 5W30 might feel safer, but can potentially cause timing chain problems in many models, depending on the vehicle. Modern engine features create specific failure modes that destroy engines. Low-tension piston rings stick in their grooves from carbon buildup, causing massive oil consumption. Collapsed hydraulic lifters from inconsistent oil pressure create valve train noise and eventual camshaft damage. Carbon-coked intake valves restrict airflow until the engine can't maintain idle. Plastic coolant housings can crack and often cause sudden overheating, depending on the vehicle. Seized crankshaft bearings from oil starvation during start-stop cycles. Each failure mode can cost thousands to repair and often leads to complete engine replacement, as damage can cascade through interconnected systems depending on the vehicle. First priority, check your oil level weekly, not monthly. Low-tension rings consume oil faster than traditional engines, and running even slightly low accelerates the damage cycle. Listen for ticking noises at idle. That's your first warning of lifter or VVT problems. Use top-tier detergent fuel to minimize carbon buildup in direct injection engines. For turbocharged engines, allow 60 seconds of idle time after highway driving before shutdown to let the turbo cool down properly. Follow your vehicle's manufacturer-recommended oil change intervals and viscosity, which may be longer than 5,000 miles for many modern cars. Watch for plastic component failures around 60,000 miles and replace proactively. Consider disabling start-stop if you drive primarily in stop-and-go conditions. Modern engines achieve impressive efficiency by operating at the edge of mechanical limits. Many advanced features can trade long-term durability for short-term performance or fuel economy, depending on the vehicle. The question often isn't whether these systems will fail, but when and how much it can potentially cost you depending on the vehicle. Understanding these trade-offs lets you make informed maintenance decisions and avoid catastrophic failures. If you want maximum efficiency, accept higher maintenance costs. If you want longevity, be prepared to override some manufacturer recommendations. Either way, knowledge is your best defense against expensive surprises. Subscribe, hit the bell, and share this video to help others avoid these costly traps.